Hello there and welcome to Module 303, Lesson 3. In this module, you will learn how a minting validator works in Aiken. In this lesson, we will revisit the minter validator that we saw in Module 303, and we will start by showing you the key concepts around minting script, and then we will restudy the logic of this validator, but this time written in Aiken. Good, so a quick recap here about two concepts that are very important regarding minting script. The first one is the redeemer, and that is a piece of data that is provided as input by the user that initiates the transaction, and it serves as an input interface that is later used to prove certain conditions of the script. And in the other hand, there is the script context, and this is an interface that shows you the relevant information about the current transaction. For example, the inputs, the outputs, the signatures involved, the minted amounts, and other relevant information about the current transaction that is being executed. If we want to know a little bit more about this, we can go to the standard library API. And if we go to the transaction part, here we can find the script context. We can see that the script context is a constructor that has two fields, and the first field is the transaction or the interface of the transaction, and the second one is the purpose of the current script. So the script purpose, it could be one of these constructors. For example, in your case, we have the mint constructor because our contract is a minting script, but it could be the case that we can execute other types of validators. And in that case, the purpose will be different, like these ones. And in second place, we have the transaction. And here we have an interface of the current transaction that is being executed. We have the inputs, the reference inputs, the outputs, the fee, the minted amount, and the signatures, and other relevant information regarding the transaction. So this is a very important part of the documentation. Here we have an overview of a successful transaction with our minting script. So in one hand, we have as inputs one UTXO with the contributor token, another UTXO that serves as fee and collateral for the transaction, and in the other part, as outputs, we have one UTXO with our contributor token, one UTXO with the student NFT that is being minted, and another UTXO that could possibly serve as change. As you can see, the student NFT doesn't have the 222 prefix. So, in order to run this smart contract, we have to satisfy four conditions. The first one is, has the input the contributor token. It's just the people who has the contributor token that can run this transaction. The second condition is just one minted token. That is obvious because we are minting an NFT. And third, does the minted token name match the one specified in the redeemer? And lastly, as fourth condition, if we exclude the prefix, is the minted token name the same to the contributor token name? If all of these questions are being answered as true or as yes, we can run the transaction. Here I am in the PBL Aiken starter repo, and here in this file I have the implementation of our minting script. So let's explain it line by line. At the start of the file, we have some imports. We say use or import from the Aiken standard library here the dictionary module. In the second line, we do the same, use or import from the Aiken standard library the list module. In the third line, we do the same, but the difference is that here we are going to make explicit which type we want to bring. And another thing that we name the transaction module as TX. In the fourth line, we do the same as the third line, and here we import some types and functions that operate on values. And lastly, we have the PBL Aiken module, where we import a policy ID and a token name type. So if we go and see them, we have them here. So in the case of the token name, we say define a type called token name, and that is just a synonym of a byte array. And here we have we define the type policy ID, and we say is a synonym of a hash of a script. And you may ask, what is this pub keyword? Well, the pub keyword means that we make this type publicly available to be called from other files. Otherwise, the compiler will say you some types are missing in your code. So far so good. If we come back to our minting script, here we have in the seventh line we have another type definition, and here we say define policy params type with a field called contributor of type policy ID. And as you can see, here we have a parameter to the script. So we can customize this script by providing different policy params, and each time we do that, we will output or we will compile a different validator. So here we start to define the validator, and here we say this validator takes one argument of type policy params, and inside of it we are going to define a function called minter that defines all the implementation and the logic of our minting script. The minting script takes two arguments, a regimer and a script context, and here we say we take a token name and a script context, and we return a bool, a true value, if all conditions are met. If something went wrong, it will return false. So an important thing that I have to point here is that, as a general rule, these inner functions has to have from 2 to 3 arguments, depending of which type of validator they are. If this was a spending script, this inner function will has to have 3 arguments. But we can't go beyond 2 or 3 because the compiler will say that it's not possible. If we if we want to add more params, we do it in this outer part right here next to the validator keyword. So far so good. So now, before to check the conditions of our minting script, we need some the information of the transaction. And the result that we want in a first phase is that we want the inputs of the transaction and the minted value of the transaction right here. So let's explain this first phase. First, we take the script context and we decompose it, or in functional programming it's called deconstructoring. It's another way to say that we take a variable and we make explicit the form of the variable. In this case, the script context is of type script context, and we make explicit and we decompose it and saying with the let keyword explicit the script context of this variable and make explicit the transaction and purpose field. Then we take the purpose field and we perform a expect. And here we expect that this script is of type mint because it's a minting script. If it's another type of a script, it will raise an error. But if it is, it will be passed and it will return this form with the policy ID. Later, then we get to the transaction variable from here and we deconstruct it and we say make explicit the form of the transaction variable, and we want the inputs field and the mint field. And if you see this dot dot, it means that you know that the transaction constructor has more fields, but we just want the input and the mint field. And with this dot dot, we say discard or ignore the rest of fields of this transaction of this constructor. So now that we have the more information, we go to the next phase of the contract, and here we take the inputs, and here we apply it to a function that takes a list of inputs and return the total value of the inputs from that come to this contract, and we save this value in the all inputs type variable. Then we take this variable and we apply the policies function that take a value and return a list of byte arrays with the policy ID, and then we save it in this variable policies. And then now that we have all the information, we are going to check the conditions. Here we are going to check the first condition, and here we have from the list module we want to import the has function, and the has function says if one element is inside this list, return true. If it isn't, return false. In this case, we want to check that the contributor policy ID that we specify in the parameter right here. We want to check if it is inside of the list of policies that come as input. If it is, return true. If it doesn't, return false. So far so good. So here we want to get the minted asset name and the amount of it with the expect keyword. So the expect keyword says expect a list from the minted value and expect a list with just one element. One element because it's an NFT, and we expect just one element with their asset name and the amount. So here we take the mint variable that we get from here and we pipe it and perform many operations on it. So here we get the mint variable and we pipe it to this function that is called from minted value, that takes a minted value and returns a value. We do a type transformation here. We from the value module we apply the result to the tokens function, and the tokens functions take a value and a policy ID, and it returns a dictionary with the token name and the quantity of that token name. And lastly, we transform that by array to a list. And we expect from the minted asset of the transaction, we expect just one because it's an NFT. And here we have the asset name of the NFT and the amount. And then, obviously, we want to check that the minted asset name is the same that we specify in the redeemer, and it's of an amount of 1. If both conditions are true, it will return true. If one is false or both are false, it will return false. So far so good. And then we say the value in this check minted amount variable. Lastly, we get from the other inputs value variable that is of type value, we pipe it, and then we perform a function that is called flatten, that take a value and return a list of triples with the policy ID, the token name, and the quantity. And here we take the result and apply it to a map function. How the map function works is that you take a list, and with the map function you take as an argument a function and a list, and you apply that function to each element of the list. In this case, from the list that results from here, we want to apply this function that we specify here that takes one argument, and then from a triple returns the second element of the triple. Lastly, the result of here, we perform the any function, and we say if some function has this condition of a list, return a boolean, and if it not, return a false. So here we perform a compare function. We compare the element that comes as input with the token name. I'm going to explain how it works later. Lastly, we finally check all the conditions. We check if the contributor has if the input has the contributor token. Here we pair the second and third condition, and we say if we check is an NFT, and lastly we check that if the minted token NFT if it's the same as the contributor token, but without the 222 prefix. If all these conditions are true, we can run this minting script. Lastly, I have this helper function, but I leave it to you to understand how it works. And you can have some hints in the API documentation, in particular in the list module. There you can see how these functions work. And lastly, there is an exercise for you that you have to implement. Here we have the comparing function that goes here, and you have to do the implementation. And basically, well, I don't want to tell you more, but you can see from the test case here how it works. And if you correctly do the implementation, this test will pass. So if you have any doubts about this or any problem, make sure to go to the Discord server, and there we can help you. Ciao!